Hello everyone and welcome to Chemistry Saga. Our today's session is a special one because the topic comes from a suggestion from a subscriber. It's a quite difficult one, but we'll try to make it as kind and simple as it can be. So without further ado, let's dive straight into it. Our subtopic for today is detergents, part of organic chemistry 2. So, what is a detergent? A detergent is a chemical compound that improves the cleaning property of water. For example, when you got a stain on your shirt or dress, what do you use to clean it? You use water and you may use some soap or some omo, right? To remove the stain. So that detergent is helping the water remove the stain and clean your clothes. Mostly that's why we use detergents for. Now there are two types of detergents, soapy detergent and non-soapy detergent. Just from the names, soapy detergent means soap. Soapy detergent also called soap, the bar soap that we use. Non-soapy detergent examples are Omo, Ariel, Persil. These ones, they do not form soap. You just wash them without forming any soap. So we first look at soapy detergents. Soapy detergents are formed when you react an alkanoic acid, a long chain alkanoic acid with an alkali such as sodium hydroxide or potassium hydroxide. Now the long chain alkanoic acid is mostly used is an octadecanoic acid. Octadecanoic acid meaning sorry, I had left my markers out. So octadecanoic acid meaning octa meaning 8 and decanoic, anything with decan means 10. So it is an 18 carbon chain alkanoic acid. So when you react the alkanoic acid, which is also called a fatty acid, when you react it with an alkali such as sodium hydroxide or potassium hydroxide, directly an acid reacting with a base forms a salt and water. That salt that we are talking about is what we call soap. Okay, so the fatty acids are 18 carbon chain molecules called octadecanoic acids, also called stearic acids. The formula for those acids is C17H35 COOH. Because it's an alkanoic acid, it has the group COOH, and since it is 18 carbon atoms, 17 here and 1 here, forming 18 carbon atoms. Okay, now you can use either sodium hydroxide or potassium hydroxide, but the advantage of using potassium hydroxide is that the soap becomes softer and it is more soluble in water, as written here. Now this is the equation for the reaction. Alkanoic acid, octadecanoic acid, C17H35 COOH reacting with sodium hydroxide. Of course, these are both aqueous, to form a salt and water. So we have water here. What is the salt? The sodium here will replace the hydrogen to form C17H35 COO negative, since the hydrogen is left, and then the sodium replaces the hydrogen to form CO negative and a positive, sodium positive. While this hydrogen here reacts with the hydroxide to form water. So this is where we are getting an equation when one fatty acid or when one alkanoic acid or when one stearic acid reacts with sodium hydroxide to form a soap. The general formula for a soapy detergent or for soaps are RCOO negative and a positive. What is R? R is always the long chain, hydrocarbon chain. Like the whole C17H35 is the R chain, the long hydrocarbon chain. While the COO negative and A positive is what is the soapy detergent. The group that symbolizes the soapy detergent. They can give you a question and ask you to identify what the soapy detergent is. What you can use to identify is this group here, COO negative, alkanoic acid group, and sodium positive. Okay? Now, before we get into the chemical reaction, let's look at the process of manufacturing soap. So we say we are reacting an alkanoic acid with sodium hydroxide or potassium hydroxide. Now, alkanoic acids or the fatty acids are found in fat. So you can either use fat or oil. Now the fat and oil have esters of fatty acids. They have many fatty acids. It's not just one or two. So before we will explain that in the chemical equation. But Soaps are prepared by reacting fat or oil with 4 molar sodium hydroxide or 4 molar potassium hydroxide. We can use both, and boiling. What is the reaction that occurs? Hydrolysis. So a hydrolysis reaction is occurring, okay, as we will see. Now you cool and add sodium chloride so as to precipitate the soap, a process known as salting out. So when you reacted the 4 molar sodium hydroxide with fat or oil, reacted with the 4 molar sodium hydroxide or 4 molar potassium hydroxide, you formed two substances or two compounds. The first compound is soap and the second compound is glycerol. It is not soap and water unlike here. Because you are using fat, you are using the esters of fatty acids, you are using many fatty acids. So you are not forming water, you will form glycerol. Okay? Now, when you form the two substances, the first one being glycerol and the second one being soap, that's the first reaction of hydrolysis. Now you have two compounds, you have glycerol and you have soap. Then you add sodium chloride. You add solid sodium chloride to precipitate the soap. You remove the soap. You make the soap which was in aqueous form, which was in solution form, you make it into solid form. So now you have two types of substances, the soap that is solid and the glycerol that is liquid. That is step 2. The process is called salting out. You filter. Now you have a liquid and a solid. So when you filter, obviously the soap does not dissolve in glycerol. So when you filter, what will be your residue? Your residue will be solid soap. And what will be your filtered? Glycerol. Okay? Then after filter to get a residue of soap and a filter of glycerol, the soap residue is washed with distilled water to remove excess glycerol and oil. Any glycerol and any oil that you initially used to react with the sodium hydroxide that is left, you remove it by washing it with distilled water. Then you can add perfumes and color to just make the soap more lucrative and looking and smell. So let's go through back the 5 steps that we say. The first step, react fat or oil which are esters of fatty acids with 4 molar sodium hydroxide or 4 molar potassium hydroxide. We said potassium hydroxide you can use because it makes the soap softer and increases solubility. After that, you add solid sodium chloride to precipitate the soap out. You make the soap into solid form so that the step that follows can be carried out, which is filtration. You carry out filtration to remove the solid soap as residue and get glycerol filtered. Then wash with distilled water to remove the excess glycerol and oil that may be present in the soap. After that, you can add color and perfume. Now let's look at the chemical equation involving fat or oil with the sodium hydroxide forming soap. Now let's look at the chemical equation when we are reacting fat, which I repeat is an ester are an esters of fatty acids. When we reacted 1 octadecanoic acid with 1 mole of sodium hydroxide, we formed a soap and water. But in this case now, we are reacting a whole fat or a whole oil, which is an ester of fatty acids with sodium hydroxide to form glycerol. Now in this case, water is not formed. In this case, glycerol is formed and the soap. So this is our equation. The esters of fatty acid is C7, we said C17 H35COH, yeah, the alkanoic acid. Now C17, as you can see, C17 H35 COO and CH2. Same for here, because it's an ester, there are three acids combined together. C17 H35 CO negative, C17, same for this one and same for this one. You are reacting them with sodium hydroxide. Note, these are three acids, 1, 2, 3. So how many moles of sodium hydroxide? 3, 1 for each. So what are the two products that we are going to form? The first one we said is glycerol. So how is glycerol formed? When we take this, the structure here, we will break it into 2. We will draw a line here and break it into 2. Sweet, simple deal. Just after the second oxygen, break the line, okay, and add hydroxide. hydroxide to each of, instead of oxygen, replace them with hydroxide. So our first product will be glycerol, which is written as C carbon, hydrogen, hydrogen again, oxygen, hydroxide, hydroxide and hydroxide. This will be hydrogen, this will be hydrogen. So you just break it into two at the point after the second oxygen, break it and attach the hydroxide group from the sodium hydroxide on each. What does that tell you? That whatever is left, the C17H35 COO group, the alkalic acid group, what do you add to that? You add sodium. So our next one will be plus C17H35 COO negative Na positive. How many moles? 3 moles. So this is your glycerol, and this is the soapy detergent. I'll explain again. You are reacting esters of fatty acids with hydroxide, with sodium hydroxide. You are going to form, your two products will be, one is glycerol and the second one is soapy detergent. Glycerol, how you will know just from the equation, from the structure is, when you have written C17H35 COO negative, then you add the CH2s on this side, okay? You break the structure into two after the second oxygen from the right side. When you break the structure into two, you also break the structure into two. So the hydroxide come and attach on this side of the carbon atoms, where the oxygens were attached. And the sodium, in the second product, the sodium comes and attaches on this side of the oxygen, where the carbon atoms were attached. So that gives you glycerol, the hydroxide groups replace the oxygen, that gives you glycerol, and the carbon 17 hydrogen 35 COO carboxyl group will be attached to the sodium. So this is the chemical reaction when you are reacting a fat or an oil, which are esters of fatty acids. I repeat, esters. That's why they are many in number. Now, the process of saponification can be asked in exam, and it's a very testable question. So let's look at this process and answer the missing letters. So fat and oil, we start with fat and oil, right? What are we adding here? First, let's mark it M. Let's say B. What is B? The first step that we say is the hydrolysis reaction. What are you adding to the fat or oil? You are adding sodium hydroxide. So B is sodium hydroxide or potassium hydroxide. What did you get? When you reacted the fat and oil, this is the fat and oil, with sodium hydroxide, what did you get? You got a soapy detergent, and what is X? X is glycerol. So X is glycerol. I repeat, you reacted a fat and oil, we have drawn the fat here. Let's say, just say we reacted the fat, we have drawn the fat here. We reacted with sodium hydroxide. We form a soapy detergent. The soapy detergent you have been given. And what is X? X is glycerol. Okay? After that, you added sodium chloride, solid sodium chloride. What is process Y? Process Y is 3 seconds. 1, 2, 3. Process Y is the process of salting out. The process where you get solid soapy detergent. You get it in solid form. It was in solution form, now you're making it into solid form. Why? For the reaction that follows to be able to occur. And what is the reaction? So when we added sodium chloride, process Y is salting out. So what is Z? We had soapy detergent in aqueous form, and what will Z be? Z will be soapy detergent in solid form. Soapy detergent in solid form. Nice, sweet and simple. After that, the step that follows is filtration. What are P and Q? P and Q are the filtrate and residue. What is the filtrate? Filtrate is glycerol. And what is the residue? The residue is solid soap. What do you do to that? You add the distilled water, you wash it to remove excess glycerol and oil, and then you can add perfume and color to make the soap more just better. Okay, what is the overall process called? The whole process here, what is it called? It is the process of manufacturing soap. And what is the process of manufacturing called? It is called saponification. So after this, let's go into the non-soapy detergent.